Hi and Assalamualaikum. My name is Aisyah. Today, me and my friends Jana wants to present about periodic table of elements. The periodic table of elements. Periodic table of elements. The periodic table is an arrangement of all the elements known to man in accordance with their increasing atomic number and recurring chemical properties. They are sorted in a tabular arrangement wherein a row is a period and a column is a group. Elements are arranged from left to right and top to bottom in the order of their increasing atomic numbers. Thus, elements in the same group will have the same valence electron configuration and hence similar chemical properties. Various elements in the same period will have an increasing order of valence electrons. Therefore, as the energy level of the atom increases, the number of energy sublevels per energy levels increases. First, Antoine Lavoisier classified elements according to certain groups such as gases, nonmetals, metals, and metal oxides. However, his classification was less accurate because he also classified light, heat, and a few compounds into the groups as elements. Besides, there were several elements that were classified into the same group but showed different chemical properties. Second, Johann Dobereiner. Dobereiner found that the atomic mass of strontium atom was similar to the average mass of calcium atom and barium atom. These elements had the same chemical properties. A similar condition occurred with chlorine, bromine, and iodine. The group consisting of these three elements was named triad. Dobereiner's classification was limited to several elements only. However, his classification showed the relationship between the chemical properties of elements and atomic mass. Next, John Newlands. Newlands arranged elements according to their increasing atomic masses. He arranged 7 elements in a row because he found that the chemical and physical properties of the first element recurred at every 8 element. He named the arrangement as the law of Octavius. The law of Octavius had only been confirmed by the first 17 elements. However, the recurrence in properties of the 8 elements showed the presence of periodic pattern in the properties of element. Lothar Meyer. Meyer plotted the graph of atomic volume against atomic mass of elements. He found that the elements of equivalent positions on the curve of the graph had similar chemical properties. For example, referring to the alkali metals such as lithium, sodium, potassium, and rubidium that were located at the peaks of the curve. Meyer also proved the recurrence in properties of elements similar to Newlands. Next, Mendeleev arranged the elements according to their increasing atomic masses. Only elements with similar chemical properties were arranged in the same vertical columns. He had left several empty spaces in his periodic table to be filled by elements yet to be discovered. He was successful in predicting the properties of undiscovered elements based on the properties of elements located above and below an element in the table. And lastly, Henry Moseley. Moseley studied the frequencies of X-ray released by various elements and eventually found a relationship between the X-ray spectrum and proton numbers. He proposed that each element ought to have its own proton number. Then he arranged the elements in periodic table of elements according to their increasing proton numbers. Moseley also left empty spaces in his periodic table like Mendeleev and successfully predicted 4 elements, namely technetium, promethium, hafnium, and rhenium, which were discovered later. The arrangement in the periodic table of elements. The modern periodic table of elements is a form of systematic classification of elements in accedence order of proton numbers from left to right and from top to bottom. The arrangement of elements is discussed from the aspect of groups, periods, proton number, and electron arrangement. The vertical columns in the periodic table of elements are called groups. There are 18 groups in the periodic table of elements. The number of valence electrons will determine the position of the group of an element. The horizontal rows in the periodic table of elements are called periods. There are 7 periods in the periodic table of elements. The number of shells filled with electrons will determine the position of an element in a period. That table explains the relationship between the proton number and the position of an element in the periodic table of elements based on the aspect of group and periods. Okay, this is the element in group 18. Group 18 consists of elements of helium, neon, argon, krypton, xenon, radon, and argonium. Elements in group 18 are known as noble gases or inert gases. That picture shows the relationship between the inert nature and the stability of the electron arrangement in an element. Noble gases are chemically unreactive due to valence shells that are fully filled with electrons. Noble gases have achieved a stable duplet or octet electron arrangement, causing the atoms of noble gases to not donate, accept, nor share electrons with the atoms of other elements. The atoms of noble gases exist as monoatoms. Changes in physical properties elements when going down group 18. Going down group 18, the size of atomic radius increased due to the increase in the number of electrons and electron-filled shells. Going down the group, the melting point and boiling point of the element increase. Increase in the atomic size of elements will increase the attraction force between the atoms. Therefore, the attraction force becomes stronger and more heat energy is required to overcome this force. Elements in Group 1. Group 1 is made up of lithium, sodium, potassium, rubidium, calcium, and francium. Group 1 elements are also known as alkali metals. The picture shows the position of group 1 elements in the periodic table of elements. Changes in physical properties of elements when going down group 1. Going down group 1, the atomic radius of elements increases as shown on the table. Group 1 elements have low melting point and boiling point if compared to other metals like iron that has a melting point of 1540 degrees Celsius and boiling point of 2760 Celsius. The increase in the atomic size down the group will weaken the attraction force between the atoms. Therefore, less heat energy is required to overcome the attraction forces between the metal atoms. Group 1 elements are soft metals with low density and float on the surface of water. These alkali metals also have a grey shiny surface at room temperature. And lastly, changes in reactivity of elements going down group 1. The reactivity of alkali metals in group 1 is due to the tendency of an atom to donate its valence electrons. The number of shells filled with electrons increases when going down group 1. This causes the increase in atomic size. The position of valence electrons is placed further away from the nucleus of an atom. When the nuclear attraction force towards the valence electrons weakens, the electrons are more easily donated. That picture Show that reactivity of elements increases when going down group 1.
Hi, Assalamualaikum. My name is Nurjana. So let's continue to element in period 3. Sodium. Group 1. Alkali metal. Physical properties. Silvery color. Solid at room temperature. Melting point 97.86 degrees Celsius. Boiling point 883.15 degrees Celsius. Sensitive, very reactive with water and chlorine. Sodium used in salt glass manufacturing and as a coolant in nuclear reaction. Magnesium. Group 2. Alkali earth metal. Physical properties. Silvery white color, solid at room temperature, melting point 650 degrees Celsius, boiling point 1019 degrees Celsius. Reactive, especially with acid and oxygen, burns with a bright white flame. By using in firework, a lightweight metal in alloy and in medical light antacid. Aluminium. Group 13. Post-transition metal. Physical properties. Silvery white color, solid at room temperature, melting point 660 degrees Celsius, boiling point 2519 degrees Celsius. Reactivity. General reactive but form as protective oxide layer that prevent future corrosion. Commonly used in packaging like cans, transposing aircraft cards, and construction window. Silicone. Physical properties. Hard and brittle with a blue-gray metallic luster. Melting point 1414 degrees Celsius. Boiling point 2900 degrees Celsius. Reactivity. React with oxygen at high temperature to form silicon dioxide, which is found in sand. Used in electricity, computer chips, solar panels, glass making, and ceramic. Phosphorus. Non-metal. Physical properties. Existed in several forms: white, red, and black phosphorus. White phosphorus is highly reactive and glows in the dark. Reactivity. React with oxygen and halogen easily. Use. Important for fertilizers, match, and some detergent. Sulfurs. Group non-metal. Physical properties. Yellow in color and has a rotten smell. Melting point around 115 degrees Celsius. Boiling point around 445 degrees Celsius. Reactivity. Very reactive, especially with metal. Used in making sulfur acid insecticide in the paper industry. Chlorine. Halogen. Physical properties. Greenish yellow gas with a strong odor. Melting point around -101 degrees Celsius. Boiling point around -334 degrees Celsius. Reactivity. High reactive, can kill bacteria. Used for disinfecting swimming pool water, in making plastics, and as a cleaning agent. Argon. Noble gas. Physical properties. Colorless, odorless gas that is non-reactive. Melting point around -189 degrees Celsius. Boiling point around -186 degrees Celsius. Reactivity. A very stable, does not react with other elements. Used in neon light, welding, and as a protective gas. Strength of physical. Atomic size decrease. The nuclear attraction toward valence electron becomes strong. Electronegative increase. Atomic size becomes smaller or decrease. The nuclear attraction toward valence electrons becomes stronger. It becomes easier for the nuclear to attract electron into the atom. Change in chemical properties of oxide across period 3. Group 1 and 2 element form basic metallic oxide when dissolved in water to alkali solution. Aluminium from metallic oxide to acid plus base. Elements in group 14, 15, 16, and 17 from acid non-metal oxide. Acid oxide plus alkali to salt plus water. Use of metallurgite. Metallurgite possess both metals and non-metals. Weak conductor of electric, good conductor of electric at high temperature, used as semiconductor, proteins of electronic microchip. Let's produce two elements in group 17. Group 17 consists of fluorine, chlorine, bromine, iodine, etchine, and tensine. Group 17 elements are known as halogen and acids as diatomic molecule. Do you know the use of group 17 element in our daily life? Next slide is a example of daily use for element chlorine, bromine, and iodine. Like we see, chlorine in bleach, bromine is one of the ingredients in fire extinguisher. Iodine is a disinfectant. Did you know, in general, group 70 elements are widely used in everyday life, especially in the fields of health, sanitation, and industry. Physical stage: fluorine and chlorine are gases at room temperature. Bromine is a liquid. Iodine and acetylene are solid. Physical properties of several group 17. Going down the group, the increase in molecule size will cause the attraction force between molecules to become stronger. The melting point and boiling point of halogen will increase because more heat energy is reacted to overcome the intermolecular force. The density of element also increase with the increase in mass when going down the group. Group 70 elements have different color. Chlorine gas is greenish yellow, liquid bromine is reddish brown, while solid iodine is purplish black. Group 70 elements have 7 electrons in the valence shell in chemical reaction. Group 70 elements have 7 electrons in the valence shell in chemical reaction. What will happen if group 70 element react with water, metals, or alkalis? Reaction of group 70 element with water, metal, and alkali. Chlorine, bromine, and iodine have the same chemical properties but different reactivity. When halogen react with water, an acid solution is formed. For example, the reaction of chlorine with water will produce hydrochloric acid and hypochloric acid. When halogen react with metals, a metal halide is formed. For example, the reaction of iron with bromine will produce iron 3 bromine. When halogen react with an alkali solution, metal halide, and water will be formed. For example, the reaction of iodine with sodium hydroxide will produce sodium iodide. Sodium iodide, 1 and water. Change in reactive of element down group 70. Did you know that the reactivity of element decrease when going down group 17? Increasing atomic size will cause the valence shell to be further from the nucleus. This will cause the nuclear attraction force toward the element to become weaker. Thus, the difficulty in attracting electrons to fill the valence shell will increase.
So that's all from us. Thank you.